Hello, Mr. Fry's Algebra 1B class. I'm looking at this Unit 5 Homework 4, Solving Systems by Eliminations, Day 2. And this is due on the 4th of March. Let's take a look at the odd ones. You're going to want to pause this as I go through and get this down. And then try the even ones on your own. If you make mistakes, don't worry about it. Correct them, and you're making progress. So let's take a look at the first one. First of all, we're supposed to be just using elimination. So by looking at number one, this system of equations here, I'm going to, there's a couple different ways I could go. I went with the x. I mean, I could have eliminated the y's by multiplying everything by 3 up here and by 2 down here, but I ended up multiplying everything on the top by a -5. So if I multiplied each term by -5, this is what this equation turns into. 1 times -5 is -5, -2 times -5 is +10, and 12 times -5 is a -60. Now I'm able to eliminate the x's because I have a -5x plus a 5x. I'm adding these systems of the system together, and I'm left with the y. 13y equals -104. I divide both sides by 13 and I get y equals -8. I go ahead and take -8, plug that into either one of these equations. I picked the easiest one that looks to me, so I picked the top one, and I plugged in the y. If you put it in this one and you work this out for x, you'll get the same answer because it's going to be the same point that they're going to be intersecting. Remember, the whole meaning of this is that this is where these two lines, if we were to graph them, if we were to rewrite these in slope-intercept form and graph them, they would intersect at -4, -8. So how did I get that -4? Well, I plugged in my y value, and then I got ended up getting, by isolating the x variable, x equals -4. Let's take a look at number 3. This one I changed the bottom to, I changed the y. I went with the y to change that to a -8. So I multiplied everything down here by a -4. In doing that, you'll see I get x equals -7. I plug in my -7 value for, I used the top one, the top equation, because that seemed easiest to me. And I get y equals 2. So -7, 2 is where these two lines would intersect. For number 5, I ended up picking the top one to change and to get rid of the y. So I multiplied everything by -3. And you can see each term multiplied by -3, how that equation changes. And then I solved for x. I get x equals 2. I plug in my 2 in the top one because that seemed like the easier one to do. And I solve for y, and I get y equals -6. For number 7, I have these two. I have to change both of them. So notice I'm using arrows whenever I make a change in the equation. So I use these arrows to signify a change. So I changed both of them so that I can get rid of the x. So I multiplied everything on the top by 5. I multiplied everything in the bottom by 2 so that I could have a 10x and a -10x. The thing about doing that, I noticed that it also changed my -30y, and then I have a +30y, and it changed this from 60 to -60, or changed it from 12 to 60 and -30 to -60. That's how I should say. It ends up being, there's nothing on this side and there's nothing on that side. When that happens, you have infinite answers. It's actually the same line. They're right on top of each other. That's why you have infinite answers. If I had some different numbers back here, and that would be no answers. They would just be parallel. This is actually infinite answers because they're right on top of each other. If we take a look at that top line and divided everything by 2, notice you'll get x minus 3y equals 6. If I took this bottom line, this equation, and I divided everything by -5, I get x minus 3y equals 6. They're the same problem. So if I were to work on this and make this into slope-intercept form, you'll see that they have the same slope, they have the same y-intercept, they're the same line. Number 9, I have to change both of these, and I picked on the y's. That seemed to be easiest. I mean, you could go with the x's and go with, 12x, but I went with the 10y. And so I multiplied everything in the top by 5, and I multiplied everything in the bottom by 2. I end up getting rid of my y's, eliminated my y's, process of elimination. 23x equals negative 138 ends up being, and when I divide both sides by 23, I get x equals negative 6. I plug in that negative 6 into the x value. I used the bottom one this time. It seemed like it would be easier. And I get y equals negative 4. So my coordinates are negative 6 and negative 4, where those two lines would intersect. And last but not least, number 11, I only had to change the bottom. First of all, I had to change it into standard form. Then I had to change it into, I multiplied everything by negative 2. So multiplying everything by negative 2 gives me y equals 4. It canceled out my x's, eliminated my x's. 4 I substitute in for that y value, and I end up getting, for my x value, negative 3 once I isolate the variable. So your point of intersection for the solution for this system of equations is negative 3, 4.